Okay, before we get going with our next lesson here, I want to just do a quick review because these two concepts I really want to drill in. So I want to make sure we have this down. So when two shapes are similar, we talked about similar last lesson. We wrote down that their corresponding angles are something and their corresponding sides are something else. Look to your notes. What are they? Corresponding angles are what? Corresponding sides are what else? Okay, corresponding angles are congruent, but the corresponding sides are proportional. And again, we're going to talk more about that today. If you're not quite sure what proportional means, we're going to have some more practice with it. So it's very important to remember, angles stay the same. The sides change lengths, but they are proportional. And we'll talk more about that. Now, just a reminder as well, because I just want to drill this in, we're not going to have to do this in this lesson, but I just don't want you guys to forget. If we're solving for a missing side length, we have to set up what's called a proportion because, again, the sides are proportional. And if you can recall, a proportion is two whats that we set equal to each other. Fractions. A proportion is two fractions we set equal to each other. So something like this, 2 over 3 equals x over 10. We call this a proportion when you have two fractions set equal to each other. Once again, we're not going to have to do this in this lesson, but these two concepts I just wanted to do a quick review of to make sure we don't forget for the future. So we got a little bit of copying we're going to have to do here. What we're talking about in this lesson is triangle similarity. Now, before fall break, we talked about triangle congruence. Now, again, congruence means it's the exact same size and shape. Similarity means it's the exact same shape, but different sizes. That's similarity. So hopefully that's making a bit more sense about what we mean when we say proportional. Proportional means the shape stays the same, the size changes. So we have a couple new postulates now, and we're going to technically ignore the congruence postulates. They don't apply. There are only 3 similarity postulates, whereas there was 5 congruence postulates. They're separate, right? We have 3 here. Let's go ahead and copy these down. So we have a new similarity here, AA similarity. Now you should know, because we already went over this, that the A's stand for angles, right? So this is angle-angle similarity. Two triangles are similar if two angles of one triangle are, let me point back, congruent to two angles of another. And again, that's because figures are similar if all of their corresponding angles are congruent. Now, we only need to know if 2 angles are congruent, right? We know that this is congruent and this is congruent. That's 1 pair. And then these are congruent. That's 2 pairs. The reason why is because it's a guarantee that this last one has to be congruent as well. If we know 2 are congruent, it's just guaranteed the last one's going to be congruent as well. And notice, again, that they don't even need to be in the same position. Like, see how this one is marked up here, but this one's marked down here? Doesn't matter. I just need to know that 2 pairs are the same. The next one we have is side-side-side similarity, right? SSS. Now, again, this is different than congruence. Congruence for side-side-side was all 3 sides are congruent, the same, right? But now, 2 triangles are similar if all 3 sides of one triangle are proportional to all 3 sides of another triangle. And we're going to practice this a bit more throughout the video and in class. But how can we tell if all 3 sides are proportional? Well, they are proportional if there is a scale factor. So, and then the scale factor is the same for all 3 sides. Because again, a scale factor takes one triangle, multiplies it by a certain number, and gives us a new triangle. We have to do it to all 3 sides. Now here's how we can check. All we have to do is create fractions for each set of corresponding sides. So how do we know it's corresponding? Well, see how 2 is the smallest number, 3 is in the middle, and then 4 is the biggest number, right? 2 is the smallest, 4 is the biggest, 3 is in the middle. So we're going to match those up with the sides over here in the same way. So 2 is the smallest number. So in my new shape, that's going to correspond with the smallest number. So what's the smallest number over here? 8. Now, of course, again, the shapes are oriented the same way for ease right now. We're going to do a harder question where they're kind of twisted and not oriented the same way. But 2 goes with 8 because this is the smallest side over here. This is the smallest side over here. So same thing, I'm going to give you a second. Try and write the other 2 fractions. We just did 2 and 8. We want the medium sides in a fraction together and the big sides in a fraction together. Okay, so the medium sides would be 3 and 12. Those are the middle lengths. And then 4 and 16. Now, if my triangles are proportional, basically similar by side, side, side. If I go to my calculator and I plug all 3 fractions in and get the same thing, they are proportional. If I don't, it's not side, side, side. So let's try this. Go ahead and take a moment, plug 2/8 in your calculator, get a decimal, plug 3/12 in your calculator, get a decimal, plug 4/16, so forth and so on. What do we get? Okay, so for 2/8, 2 divided by 8, we get 0.25. For 3 divided by 12, we get 0.25. Hey, so far so good. And the last one, 4 divided by 16, is also 0.25. So what this means is we have the same scale factor from one shape to the next. If all of these fractions come out to be the same thing, that's good. That means these shapes are similar. They are proportional. If these decimals do not come out to be the same thing, say for example, this was like 17. Well, this would then give us a different fraction, and then we'd say no, these triangles are not similar. But because, again, we have the same number in all 3 cases, that's good. That means they are similar. Now we have one more, and it's going to work kind of the same way, but there's 2 pieces here because it is side, angle, side similarity. So we need to have 2 things. We need to have 2 sides from one triangle proportional to 2 sides from another triangle, as well as the angle in between those sides has to be congruent. So far so good. This goes side, angle, side, right? That's good. Side, angle, side. The angles are the same, so that's good. But I'm going to have to do the same thing where I create I only have 2 fractions here. Yeah, that I'm going to have to do. And I need to see if we end up with the same numbers when I create those fractions. So go ahead, I'm going to create the first one just to remind you, and then we can do the second one. So again, there should be some scale factor getting me from this shape to this shape, or vice versa. It doesn't matter the way we think about it. So 2 is going to go with 4 over here, because again, 2 is smaller than 3, 4 is smaller than 6. Those are going to be corresponding sides because they're the small sides. So what's going to be our other fraction? Well, we have 3 over 6. Those sides correspond to each other. So again, if they're proportional, they would go together. You could think about it like that. We'd take 3, we'd multiply by something to get 6. We'd take 2, we'd multiply by something to get 6. So do these come out to be the same decimal when we divide them? They do actually. 2 divided by 4 is 0.5. 3 divided by 6 is 0.5. So what this means is this is side, angle, side similarity. The angles are congruent. The sides are proportional. Boom. Yes, that's side, angle, side. Once more. If these numbers do not come out to be the same, we say no. No side, angle, side similarity. Let's go ahead and try a couple examples. So we have some given information here. Go ahead and pause the video whenever you need to copy down the info. What I recommend you do is copy the pictures and then label these angles in your pictures as well. So we want to determine again whether or not the triangles can be proven similar. Take a moment to copy. Okay, and I'm going to go ahead and label it as well. So measure of angle B is 140, so I'm going to put 140 here. Always a good idea to label our pictures. C is 15, Y is 140, and X is 25. Now, hopefully we can see we are going to try and say if these triangles are similar, and again, we can just say no if not. If yes, we have to say which postulate, and there's only 3. Angle, angle, side, 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 angle, side. Now, based on the information we have here, there can only be one possibility. If these triangles are similar, it has to be by angle, angle, because there's no sides given to us, right? I don't know the lengths of any of the sides. Therefore, of my 3 postulates, it can't be these 2. We don't know any sides. Now, that doesn't mean that it has to be this. Again, our answer could be no, because what we need is 2 angles congruent. Now, we have 1 so far, right? We know that angle B is congruent to angle Y. But 15 is not 25, right? So that's not congruent. However, what we have to check for is, what's this missing angle here? It's possible this missing angle could be congruent, could be 15. It's possible this missing angle could be 25. So pick a triangle, it doesn't matter. I'm going to go ahead and pick this one. Let's find angle A and see if it's actually 25 degrees. Because if it is, that's 2 pairs of angles that are congruent, and that's good. You should know how to do this. This is 140, this is 15. Find the missing angle. All 3 add up to 180. Okay, so 180. Take away the 140. This is the shortcut, guys. Minus 15. This is going to give us angle A. So 180 minus 140 minus 15. Whoops. Hey, this does give us 25 degrees. So we actually do have 2 angles congruent, and in fact, that does mean all 3 are going to be congruent. If I found over here, I would have found this was 15, and then these 2 would be congruent. So we can say, yes, these triangles are similar. Bi, angle, angle. We had to do a little bit of extra work. If you're missing an angle, you need to find it to see if it actually turns out to be the same as one of our given angles. Okay, let's try the next one here. So once more, copy the picture and label the information. I'll give you a moment to do that. Okay, HI is 6, HJ is 6, IJ is 4, KM is 5, LM is 5, and KL is 3. So to start off with, we always want to see what postulate we're checking for. We only have 3. And what we're checking for is based on what's given to us. Now again, it's possible our answer is still no, but it helps us to keep in mind which one could it possibly be. Now based on our information here, that's a 3 and that's a 5. Which one could this possibly be based on the information given? Well, if it is anything at all, it would be side, 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 because I have side, side, side. I don't have any angles given to me, right? So we're checking for side, side, side. That doesn't mean it is side, side, side. We have to check. Now again, what we have to do is, I've got 3 sides here, right? This is a triangle. That means I need 3 fractions, taking one side from one triangle to the corresponding side of the other triangle, and seeing if, when I divide them in my calculator, if we end up with the same thing. So I want you to try it. We did it just here, right? We got our 3 fractions. This is the same thing. Remember, how we know what goes together is the small sides go together, the medium sides go together, the big sides go together. Go ahead and try and get your 3 fractions. Okay, now it doesn't matter which one I put on top. I'm going to go ahead and put these numbers on top over here. You just have to be consistent. If I choose to put 4 on top, then the 6's have to go on top as well. Yeah. So there's all of my sides from one shape. I need the corresponding sides on the bottom. If you put the 3 on top, that's totally okay. You're going to get the same conclusion. You're going to get different numbers, but you'll end up at the same conclusion. So 4 is going to go with 3 because both of those are the smallest sides in their triangles. And then obviously 5 and 5 are going to have to go here because if 6 and 6 are the same, then 5 and 5 are the same. Those correspond. So let's see, do we get the same numbers? 4 divided by 3 is 1.33. 6 divided by 5 is 1.2. This is not true, right? That those are not all the same number. So what this means is no, they are not similar. Yes, it looks like it could be side, side, side. But we need this to be true, and this is not a true statement. These fractions are all not the same, so our answer is nope, not similar. They are not the same shape, right? Again, similar means same shape but different sizes. These are going to be differently shaped triangles. Okay, let's try the last one here. So once more, please copy and label. Okay, we got RO is 5. We got SO is 6. We got NO is 12. And OP is 10. Now we do have 2 triangles here, right? This is one triangle. Here's our other. So we got to maintain that focus. Now looking at the information we have here, again, here's our 3 possibilities. This one's kind of tricky because based on the info we have, it looks like I can't do any of them, right? I don't have all 3 sides. I only got 12 and 10. I don't have this third side. Side, angle, side. Well, yeah, we have 2 sides, but I don't got any angles marked. And again, same thing. I don't have any angles marked, so it can't be AA. However, there is an angle in this picture we can actually mark congruent, and we just need to use our knowledge from first semester. Take a moment. What angles in this picture can we mark congruent? These ones right here, these are called vertical angles. Remember that vertical angles are congruent. So if I look at one of my triangles, this actually is side, angle, side. So far, it could possibly be side, angle, side. We've already got one angle marked congruent, but because there are sides, and there's 2 of them, 2 in each triangle, right? I'm going to create 2 fractions still, using one side from one triangle to the corresponding side of the other triangle. And I want to see if we end up with the same numbers. I want you to try this. Here's one triangle. Here's the other. Remember, the sides that go together are the smallest sides together and the biggest sides together. Be careful. Go ahead and try this. Okay, so I'm going to go ahead and choose to pick 5 from this triangle. Remember, you didn't have to put 5, yeah? If I pick 12, if I pick 10, if I pick 6, as long as I did everything else correct, we're going to come to the same conclusion. So 5 in this triangle is going to have to go with 10. That's because 5 is the smaller side here between 5 and 6. 5 is smaller. On this triangle, 10 is smaller. So again, corresponding means just like that. The smalls have to go together. The mediums have to go together. The bigs have to go together. So that means I need to have 6 over 12. Biggest side, biggest side. So hopefully you can see that this is actually going to end up at the same number. This gives us 0.5. This gives us 0.5. That's good. What this means is yes. We would say by side, angle, side, these triangles are similar. We have a congruent angle. We have that the sides are proportional. We're all set. So we're going to practice this more in class because you kind of just followed along right now before we do the assignment to make sure we're definitely set with this.